Linear equations in one variable. In this video, we're going to cover 4 objectives. Number 1, we're going to solve linear equations using properties of equality. Number 2, we're going to solve linear equations that can be simplified by combining like terms. Number 3, we're going to solve linear equations containing fractions or decimals. And number 4, we're going to recognize identities and equations with no solutions. So the first objective we have is we're going to solve linear equations using the properties of equality. So we need to define some of the terms that we're talking about here. One of the first pair of terms that we need to talk about is an expression versus an equation. An expression is when you have like a one-sided equation. So it is a combination of variables and numbers, but there's no equal signs. Numbers and variables. An equation is then like two expressions put together that we are stating have equality between them. Now later we'll talk about less thans and greater thans and our inequalities, but right now we're dealing with an equation and two expressions that have equal value. So for the purpose of solving, we are looking for finding the values for the variables. That make the equation true. The format that we're going to be looking at for linear equations in just one variable looks like this. AX plus B equals C. Now, with those variables there, A, B, C, there's an X. A, B, and C are all going to represent real numbers. And then the variable X is our variable. The only thing of note is that A can't be 0. Because if A is equal to 0, then our variable is gone from this. So now that we have some terminology behind us, let's talk about the two properties that we're working with here. We have the addition property of equality and the multiplication property of equality. So the addition property of equality says that if we know A equals B, then we can add a third piece, we'll call it C, to both sides, and it is still equal. So we are adding this plus C on both. The same is true as if we subtracted. So even though we call it the addition property of equality, this is also subtraction in here. So we could also subtract something from both sides and it still be true. So for the multiplication property of equality, if we start out with two things that we know are equal, we can then multiply in a third piece and they are still equal. So we are multiplying in C on both sides. The only thing of note for multiplication here is that C just can't equal 0. But this is also going to be our division as well. So multiplication property or division, we can divide something from both sides. Example 1, we want to solve x minus 5 equals 12. And we want to solve it for x. So once you identify where your variable is, we're going to try to leave that x where it is, and then we're going to move any other numbers around it to the other side of our equal sign. So you always want to make note of where your variable is and where your equal sign is. So since we currently have a minus 5 connected to the x, in order for us to get rid of it, we're going to use that addition property and we are going to add 5. And as long as we do it to both sides, it's going to keep everything balanced with our equal sign. So the reason why we are adding 5 is because we had a subtract 5 in our original equation. -5 plus 5 actually cancels out to 0. So then we are left with just our x on the left. And then on the right, we have 12 plus 5 to give us 17. So our final answer is x equals 17. Now, even if the problem doesn't state it, you should always check your work. So we're going to go back to the original equation, x minus 5 equals 12. And instead of the x, I'm going to plug in 17. 17 where the x was. And then let's check. 17 minus 5 gives me 12, and that equals the other side, which had the 12. Objective 2. Solve linear equations that can be simplified by combining like terms. Example 2. Solve 8x plus 8 minus 4x equals 10 plus 2. So when we are combining like terms, that means we want to just look on one side at a time. So we are only going to look on this left-hand side for a moment. And we are looking to see if there's anything that has similar format. So do they both have an x? Are there things that it both don't have any variables? So over on the left, we have this 8x and a minus 4x. And because they're on the same side, we're going to put those together. So 8x minus 4x gives us 4x. And then we're just going to bring down that plus 8. There's nothing else that we can combine here on the left-hand side. So let's look at the right. On this side, we have both a 10 and a 2. Both have no variables, so they are like terms, and we can put those together. So 10 plus 2 equals 12. It's ideal to do your combining like terms first before you get into those addition property of equality and start moving things across the equal sign. So now, like example 1, we want to move this plus 8 away from the variable term. So since it's positive, we are going to subtract it. Subtract the 8 from both sides. 8 minus 8 cancels, and we are left with 4x on the left. On the right, 12 minus 8 is 4. Now we get to use that multiplication property of equality. We want this x by itself, so we are going to divide both sides by that 4 in front of the x. So 4 divided by 4 cancels to 1, which leaves us behind just the variable x. And then on the right, 4 divided by 4 is 1. And then again, we should always check our work. So over on the right, I'm going to write the original equation. And then anytime I get to the variable x, I'm going to plug in a 1. Order of operations here. So we're going to multiply first. 8 times 1 is 8. 4 times 1 is 4. Then we're going to combine like terms on both sides. So 8 plus 8 is 16. 10 plus 2 is 12. And then I've got one more on the left here. 16 minus 4 gives me 12 equals 12. We're good to go. Example 3. Solve 7y minus 5 plus y equals 7 plus 5y equals 18. So we're going to start by combining like terms. So we're going to look just the left-hand side first. We have two terms here that have a y, so we're going to combine those first. So we have 7y plus y, which gives us 8y, and then we're going to bring down the minus 5. Then on the right-hand side, the terms that we can combine are both our positive 7 and our negative 18. So when we combine those, 7 minus 18, we get negative 11 plus 5y. I'm done combining like terms, so now I'm going to start adding and subtracting to get all of our terms moved around. This time I have a y, our variable, on both sides of the equation. So at this point, there's a lot of options. I could move the 8y to the right, or I could move the 5y to the left, or I could tackle my negative 5 or my negative 11. Any of those work. I personally like to go after the variables first, because then I get them where I want them to be. So I always move the variables so that they are going to stay positive. That's what I would like to do. So I am going to subtract the 5y from both sides. That way, 8y minus 5y, I get a positive 3y. If I had moved my 8y, I would have ended up with a negative variable. So that's what I'm just trying to avoid. I'm going to bring down all my other terms. Now I'm going to move my 5 to the other side. And again, since it's in minus 5, we're going to add 5 to both sides. So I have 3y equals negative 6. And then the last thing I'm going to do is divide both sides by my coefficient, that 3. And I end up with y equals negative 2 as my final answer. We're not going to check on all of the problems that we do, our work, but anytime you are working on your homework or on a test, you absolutely should be checking your work. Example 4, solve 3 times 2w plus 4 equals 9w. So this is the first time we've seen a parenthesis in here. So we're going to use our distributive property. Distributive property means that whatever is outside of the parentheses is going to get multiplied into everything inside the parenthesis. So we're going to do 3 times the 2w plus 3 times the 4. So 3 is going to get multiplied to both of those pieces. So 3 times 2w is 6w, and 3 times 4 is 12. Clearing our parentheses is our first step. Then we can look to see if we can combine like terms on both sides. Then we look into moving around our variable. So I'm going to subtract 6w from both sides as my next step. That's going to cancel my w's on my left. But another thing of note here is that you never want one side to be empty. Never allow one side of equation to be empty. It causes too many problems, so we always want to make sure that there's at least one term on both sides at all times. So on this problem, I definitely would not have wanted to move that 9w because then it would have left the right side empty. So I have 12 equals 3w. I can divide both sides by 3, and I get w equals 4. Notice this is the first time we finished a problem with our variable on the right-hand side. That's totally fine. So your variable can end up on the left or the right and be good. Objective 3, solve linear equations containing fractions or decimals. So I listed out the steps here for how to remove fractions and decimals from the problem. So the first step you're going to want to do if you want to clear out the fractions and decimals is you're going to want to multiply both sides by the least common denominator, the LCD, and that's of all of the denominators in the equation, looking at both sides. Then you're going to go through the same steps that we've been working on. You're going to use your distributive property to get rid of any parentheses. You're going to combine like terms on both sides, then add and subtract to move around your terms, and then you would use your multiplication property at the end to isolate your variable. And last but not least, always check your work. For least common denominator, let's take a moment and just refresh how do we find a least common denominator. So first thing you need to do is identify all your denominators. Now, if you haven't heard that term in a while, denominators means the bottom of the fraction. So we are looking only at the bottom of fractions, and we are trying to find the magic number that we can multiply into all of our terms and remove the fractions from the problem. And we want to do this in one step to make our lives a little bit easier. So let's imagine that we have a bunch of different fractions in our problem, and the denominators look like a 6, let's say a 5, and let's say a 2. Say those are our denominators. It doesn't matter what's on top of them. So the first thing you want to do once you identify your denominators, 6, 5, and 2, is we want to list out the multiples of each of those numbers. So if we count by 6s, we would then have 6, 12, 18, 24. Notice that I'm just like adding 6 as I go down this list. And then it keeps on going. Then we're going to repeat that for all of those denominators. So 5, 10, 15, 20, and so forth. Again, just adding 5 down that list and keep going. And then the same thing with our 2s. Now, once we've done that, we've gotten a little bit of a start on each one of them. Notice I've got like ... Like this list keeps going. Then I want to start looking for the smallest one that they all have in common. So that's where that least is coming from, that term least. So I'm looking for the smallest number that all of these columns have in common. So like, for instance, there's a 10 and both the 2 and the 5, but notice 6 doesn't have a 10. So that doesn't work. It's got to be the same number in all of the columns. So had I kept going on my 2s, eventually I would get to the number 30. And that's what we're going to end up picking, is 30, 30, and 30. That is going to be your least common denominator. 30 would be the magic number that if we multiply it into all of our terms, then everything that had a fraction bottom would reduce out a fraction fully from the problem. Example 5, solve 3m over 2 plus 1/3 equals m minus 3/4. Now you could solve this problem and leave the fractions in there. You would need to get common denominators and so forth. But we're going to go with the route that we just discussed, finding that LCD in order to remove all of our fractions from the problem in one go. So the first thing I'm going to do is identify what my denominators are. So I have a 2, a 3, and a 4. So off to the side, I'm going to take those 3 numbers real quick, and I am going to start listing out the multiples underneath each one. So if I list the multiples of 2, it's as if I am adding 2 as I go down. Do the same thing with 3. Same thing with the 4. And then if you need to and you start to kind of notice where it might be going, keep going until you find the one they all have in common. And in this case, it looks like our LCD is going to be the number 12. That is the smallest one they all have in common. So that means I'm going to go back over here and I'm going to multiply 12 into the whole problem. So I'm going to use yellow just to show it, but this 12 is going to multiply here, 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 and here. Everything, whether it has a fraction or not, everything is going to get the 12. Now, the way I like to multiply whole numbers into a fraction to make my life a little bit easier, I will show you this off to the side over here. The first thing we've got is 12 times that first fraction, 3m over 2. So what I like to do is instead of multiplying that into the top and making bigger numbers, I start by looking at dividing. Because I know this number is the multiple of this bottom number, I'm going to divide it and it's going to give me a whole number answer. So 12 divided by 2 gives me the number 6. And then I'm going to take that 6 multiplied by the 3m. And that gives me 18m. So again, I'm going to repeat that off to the side here so we can do it for the next one. We're going to take the whole number 12 times the fraction 1/3. So 12 is a multiple of 3. That's how we got our LCD. So we're going to do 12 divided by 3, and that gives us 4. And then I'm going to take the 4 times the 1, and that gives us the number 4. On the right, 12 times m gives us 12m. And then our last one, we have 12 times 3/4. Again, 12 is a multiple of the 4. So 12 divided by 4 gives me 3. And then 3 times 3 gives us the number 9. Notice with that one step of removing our fractions, it makes this problem a lot easier to work with. So now I'm going to focus on getting my variables moved together, but I'm going to make sure they end up on a side where they're positive. So I'm going to subtract 12m from both sides. 12m minus 12n cancels. 18m minus 12m gives us 6m, and everything else comes down. I can move that positive 4 to the other side by subtracting it. 4 minus 4 cancels. So we have 6m equals negative 9 minus 4 gives us negative 13. And then our last step, we're going to divide both sides by 6. And we are left with m equals negative 13 over 6. This is the first time we've had a fraction in our answer. You always want to check fraction answers to see if you can simplify it anymore. See if there's a number in common from the top and the bottom that you could pull out of the problem. If not, then we leave it as is. We're going to leave these as improper, so it's okay that the number on top is bigger than the bottom. We don't need to switch this into like a mixed number. All right, objective 4. We're going to recognize identities and equations with no solutions. Example 6. Solve 4x minus 12 equals 4 times x plus 5. So first thing I noticed, there's no fractions or decimals to work with. So we're going to start by clearing out the parentheses here. So the 4 in front of the parentheses needs to multiply to both things inside. So 4 times x gives us 4x. 4 times 5 gives us 20. Now I'm going to focus on moving my variables. I want to get them together on one side, preferably positive. So I'm going to subtract this 4x from both sides. Bring down what's left. And then this is where people panic, because all of a sudden you notice there's no more variable involved. And this is where people are like, oh, I must have made a mistake. Let me go back. Let's double check it. If your work is great and you just happen to end up here where there is no more variable, this is a type of situation that's called no solution. So no solution means that there is no number in all of our numbers that could be plugged in for x, and that would make both of these sides of the equation equal. So your final answer would be the no solution here in a box, or another word that you might see pop up is called a contradiction. That is the fancy term for a no solution here. The two sides contradict each other. They are not equal. Example 7. It says solve 8x minus 3 equals 2 times the 4x plus 1 minus 5. We have no fractions or decimals. So then let's look to see if there's any parentheses to clear. So we are going to distribute the 2 by multiplying it to both parts inside that parenthesis. 2 times 4x gives us 8x. 2 times 1 gives us 2. Then we can combine like terms on each side. This side over here on the right has 2 things that we can combine, plus 2 and the minus 5, which gives us negative 3. Then we'll switch into looking to get our variables together onto one side of the equation, preferably positive. So let's subtract 8x from both sides. And then you'll notice this is a lot like the last problem. All of a sudden we realize, wait, the variable has completely disappeared, but it is slightly different than the last one. This time when your variables disappear, the 2 numbers that are left do equal each other. So instead of this being a contradiction, this is actually something called an identity. So I'm going to put it underneath here in the box. This is called an identity, which means that any number for x can be substituted back in and both sides would equal. So you can put identity, or you can put the phrase all real numbers, because any of those real numbers could be plugged in and work for this equation. And the only difference between example 6 and example 7 all comes down to whether or not the 2 items left equal or don't equal each other.